So probably we can start. Continue with the SQL join superpower. It's very useful, and you will use it a lot in when using SQL, if you will have the chance to work with SQL. So it's good that you understand the basics and the details, then it's much easier to use it and to avoid any mistakes when you are using, because it has some traps if you do not know exactly how it works. And that's why I've included in the second part of presentation the information about some of the traps. By the way, let me start sharing the screen. Okay. Okay. Fine. Okay. So yeah, I was saying that there are some traps that join has for us, and we have to be careful with the joins. And I will show you some of those. Of course, there are some other traps which might appear. Maybe even I don't know yet all of them, because I didn't. I would say I didn't gone through that trap, so maybe I even don't know it yet. But I try at least to show you some, maybe the most traps which has the highest chance that you can go through. So yeah, let's go through this. So join is good, but it's also bad because it has traps for us. And let's see what traps we have from join. So one of the trap is losing either the left or right side of the joins outer rows. And when it happens and how to avoid the trap, let's see in this example. So we have a left join result here, and you can see that we have this is the script for this left join. And you can see that we have two tables, person table and employee table. Person table, which is on the left side, and employee table, which is on the right side. And you saw those tables in the first part a lot. And we join those two tables on business entity IDs column. And you can see those two here. This is for person table, this is for employee table. And in the result set, we can see that we used a left join. So we have the left side of the person table is preserved. So all the rows that exist in the person table, we have them here. 1 second, let me laser point. So we have them here. And for the left side, or left table or employee table, we take only the records that have match with the business entity ID from person table. So what we have all the table from person, all the records from person table, and for some of the records we have nulls here. So as you can see here in left join, we have a condition and nothing else. And now when this trap might occur, or when it can appear, so that these outer rows disappears, it might appear when, for example, you use this script, which is the same as this, and you just add where clause. And in where clause, you specify that you want to filter out by the business entity ID from this left table, from this right table. by business entity ID from employee table, which is the left table. And you specify you specify the IDs, exactly what IDs you want. And in that case, you can see that you will lose all these records. They will be lost. Maybe you know that, maybe not, but sometimes when you want to finish something quickly, you can miss this part. You can write, for example, left join, you want to join on business entity ID, and you would like to see these IDs from left table, but you want also to see the nulls. I mean, you want, and doing the left join, you assume that you will have all the tables for the left table, which is person table. And you assume that if you put in where clause, you would have all these records from the left table and these records, 1, 2, 4, 6, 7. While it's not the case, it will be because you will have this result. These outer rows will be filtered out. These 4 rows which are preserved, they will be filtered out. So this is the case when the preserved rows, when the preserved table can have some rows that are filtered out by where clause. So why it happens that where clause excludes these tables? So if I go, for example, to the order execution, one second. If we look here in the order execution of the query, we can see that we have this from and join, which comes first. So it takes the tables, joins it, and here we have the on clause. But then comes where, which filters even on more granular level. So it means that all what we have here, for example, 9 records, and here we mentioned that we want only 7 records, then those 2 will be filtered out. That's why it's important to understand the order of the execution, because where is kind of final filter of the join. And that's why those 2 rows executed, those outer rows are filtered out. So it's because where clause comes after from and join, and it kind of filters after those once again. That's why if we go, one second, if we go back here, it filters out these 4 rows. Because if we don't use where, we will have this result. So this is one of the trap which might happen. Okay, here we have quite a small table, quite small result set. That's why it's quite easy to notice. But sometimes the table can be quite big with thousands or maybe even million rows, and you cannot see it visually. I mean, you just theoretically know that there is such trap, and you should be careful when you use where clause. And this happens usually when you use in where clause a column from the right table. Because if you would use, for example, in where clause the column from this table, then in any way it will filter out only 7, but you already know that you work on the left table. So I would say that if you want, in this case, if you want to have all the rows from here, from the left table, and for the right table you want to have matches only for these 5 elements of these 5 values, then this part business entity ID in these values, you should put it here in on, and it would be on business entity ID from employee table equal to business entity from person table and business entity from employee table in these values. Then it will keep all these rows from the left table, preserved rows, and it will keep on the right side these values, and here it will indicate null, and here also null. So that would be one solution for this trap. So in order to avoid the trap, always when you have left join or right join, check if in where clause you have this filter, which is based on the non-preserved side, on the column which comes from the non-preserved side of the table. So be careful here, because it could happen quite often. Okay, let's see another trap. This one, actually, it's quite similar to the one I explained before, but the difference is that we have here a multi-join query. It means that we have joined between not two tables, but between three tables. So what is the trap? The trap is that we transform the outer join result set into inner join result set. And let's see in the example how it happens. So we have, again, we have this script for left join, for joining two tables. It's person table and employee table. And we again join on business entity ID. And we have this result set. Okay, this is the first part of the join. Then we have a third or second table that we join to this result set. And it's an inner join. You see, this part is same as this script. And then we want to add one more table. And this is, for example, rates. We want to see the last name from the person table. Then we want to see the job title from the employee table. And there is another table, which is employee history, and which brings us the rates. These are hourly rates per job title. And for example, again, the same HR department wants to see the first name, job title, and the rate. And it means that we have to join three tables. By the way, this employee history table, as you can see, is also joined on business entity ID. It has also business entity ID in it, so we join on that column. So what's the trap? Now you can see that we have in the left join, we have nulls in the left join result set. And when we join the set table, we say again that we take the business entity ID from the non-preserved side, which is employee table, from the join of these two tables. So we had person table, employee table. Person table is the non-preserved, the preserved side. Employee table is non-preserved. And now when we have a set table, which is employee pay history, and it joins already on the result set of the first two tables, and it takes from this result, it takes this business entity ID and says that okay, let's do an inner join based on this business entity ID, and in that case, these nulls again will be excluded because the business entities IDs from employee history, which brings us rates, is joined. Imagine that here you would have another column of business entity IDs from pay history table, and it joins based on the values that are matching. In that case, this result of left join would take only this part of records, and then we will lose again this part, and in that case this left join would be like an inner join, because it would have only these values which are actually matching with the person table. So that's another trap. It's similar to the one before, but the difference is that it has three tables. Now we have an input as a result set of left join, and the second input is the third table, which is pay history. So be careful when you do such kind of join. Always be careful what columns you use in this on clause, in the predicate, in order to avoid this, in order to avoid losing some fields from here. Because in that case, if you lose these fields, you don't know that there are some people that don't have job title. And maybe it's important to know that these people have job titles. Or if you count all the people, then finally you will have not 9 people, not 9 persons, but you will have 7, and it would not be correct, because actually you should have 9. So that's the second trap, and it's also the one which you should keep in mind. Any questions for now, guys? Let me see. No? Okay, no. Let's continue then. Okay, let's see the next step. This one trap is related when we are counting rows, and the trap consists that we can count some additional rows which should not be counted. And let's see how it happens and why it happens. So when it might happen is when you use count, when you use to count all rows. So let's see what we have here. Again, we have the left join result set, and it brings data from customer table and sales order header. So what we have customer ID from customer table, we have customer ID from sales order header, and we have sales order ID, and we have total per sales order ID. So what it means, we have a table that have all customers, and then we have a table with sales only, and the table has a sales order and the customer. So some customers might be in our database, but not all customers have sales order. They didn't purchase anything. So that's why here we have total due null, because there are no sales order created. The customer didn't purchase anything. So what we did, we wanted to see the customers and the amount each customer paid. And here we can see that the customers with ID 3, 4, 7 don't have any orders. Now we want to count, we have this left join, and we want to count the number of orders each customer has. So we have here 12 customers, but only 7 customers have not only 7, but 1, 2, only 3 customers have orders. And we have actually less customers too. We have 1, 2, 3. Yeah, we have less customers. We have only 6 customers. So we have 6 customers, but 3 of those don't have orders. But we want to count how many orders each customer have. So what we do for that, we should use count in order to see how many orders it has. One option, and it's the one which has the trap, is using count like this, with this star inside, which means that it counts all the records. It counts all the rows. So it will count 12 rows here. So we count, we make this left join, and we just say that we want to count all the rows and group by customer ID. And here we have the result. It takes the customers, we have 6 different customers, and it counts the all rows. And considering that this customer which don't have order is also a row, and doesn't take into consideration that it's null for sales order ID, it just shows you 1, the same for 4 and 7. So it tells you that here, if we do like this, it tells you that it has 1 order here, which is not true. And for this, for others, it calculates correctly because, well, they have orders here. But anyway, it calculates the orders, but it doesn't take into consideration that whether we have here, a sales order ID or not. It just counts the orders, and that's all. It just counts all the rows. What's the solution for this? So we should, in this case, we should, when we do such kind of join and we want to count only those that have value inside, we should use specifically the name of the column. So it's, for example, in that case, we use the customer ID from the sales or the header table, which is this. And it will count only the rows where we have values. So here we have customer ID, here we have, so it calculates, you see 3, 2, 4. And for those, it just shows null because there is no values here for custom ID, which means that there are no orders for these customers. So these figures are correct now. So it's very important, especially if, for example, a sales manager will ask you to calculate or to bring a list of the customers and the number of orders they have. So be careful, count the null, count only the values, because otherwise this can count, it can show the counts where actually there are no values. And also be careful to, when, for example, you select the count, for example, it might be the case that even in sales order ID, we could have a sales order here, but here it could be null. Then we should use only the columns where we assume there are no nulls, because otherwise it again will show us the figures incorrectly. Okay, so do you have any questions? I hope it was clear enough. Okay, let's see the next trip. Okay, fine. So this is the trip when we can have some duplicated records. Let's see when it might happen. So we have an employee table, and here we have, it's not the whole table, just the focus on marketing team. Here we have the marketing team, and we have employee pay history. It's the table which have the paid rates and the business entity ID, which is related to this one. And we have the hourly rates and the pay frequency, how often it's paid. So what we need, what our marketing manager wants to see, he wants to see, or she wants to see if the monthly pay for each of these job title, in order to calculate then finally maybe the total amount, or just want to see what's the budget for the marketing department. And in that case, you have just to select the marketing team from this table and then join with the pay history table and calculate the monthly pay, which is this rate multiplied by 8 because it's per hour, and then multiplied by 20 working days per month. That's an approximate number, 20. I assume that we would have on average 20 working days per month. So we have to calculate this and provide this information to our marketing manager. Okay, how we do that? Of course, we again use an inner join in order to select the pay rates only for marketing specialists, which means that we take from pay rate history only the values which are matching with the values from employee table based on business entity ID. And you can see it here. We take the employee table and inner join it with the pay history table, and it's on business entity ID. And also we specified that we want only marketing. The job title should have only marketing. And then we, of course, group by business entity ID and job title in order to see per job title the amounts here. So fine, we did that. We provided this list to the marketing manager. He has the monthly pay or monthly salary per each job. And he says, wow, great, that's fine. But what about, but it looks a bit suspicious, my salary, because actually my salary is lower than that. It's not 14,000. And you say, you think that's strange because it seems like I've did everything as I should, but actually that's not. And probably maybe you've already noticed that from this table. If not, then I will show you in the next slide what was wrong. So it's mostly the same slide, the same table with employees, the same table with pay history. Only here we have some changes in the script and also a change in the result. So what's the difference? If you look in the slide before, in the script before, we said that first of all, if you see, we have, for example, for this business entity ID, which is 1616, it's marketing manager. Okay, yeah, this is the marketing manager. So we see 16, it's once, then we see another record of 16, then we see another record of 16. That's strange. Why we have 3 records repeating? So these are duplicates. Okay, let's see what other columns we have. Rate change date. It means that we have here the rates that changed. So in 2009, it had a rate of, let's start with 2007, it had the rate of $24 per hour. Then it changed on 2009 to 28. The rate increased for marketing manager. And the latest one on 2012, it increased to $37 per hour. So when we calculated, we said that we want to group by, we sum, here you can see we sum this rate, and it summed 37 with 28 and 24. And that was actually not correct because this is the only rate which we should use. So one tip here is that whenever you see history in the name of table, pay attention to that. It means that some of there are high chances that we will have duplicates. And here we have them. So that's why his salary was actually bigger than it should be. And what we can do in this case. So we know that we have 3 records for marketing manager. How we can solve that? We can start with the idea that we need only this one. So we should exclude this one. There is such function, row number in SQL, which we can use in order to assign a row number within a certain partition. And here the partition is done by business entity ID. So it will take 16 business entities, which has this ID 16. And within that partition, it will order them by rate change date. So it will, and I mentioned that as descending, which means that it will take from the highest, from the latest date to the earliest date. And we call it as row number. And then, so I have this partition per each of the business entity ID. So here we have 3. Within this partition, we have 3 records. For 17, for example, within this partition, we would have only 1 records because there are no duplicates. So now we know that we have on top, within these 3 records on top, the first one would come with this one because we have arranged this by this order by. That's why in the on clause, we mentioned that we would like to join on business entities IDs, on marketing, take only marketing team, and row number 1. So between these 3 rows, it will be, this one would be row number 1, row number 2, row number 3. So we say that we want only to take row number 1, which is the latest one. So that's why it will take only this rate. And in that case, we will calculate the correct salary or the pay, the monthly pay, which the manager has now, and these 2 will be excluded. So this is a way to, this is a solution for the above problem. But of course, you never know when you have something like this. In order to avoid such trap, always check whether you have duplicates here. So I would say that you go to the, don't know if you already used the SMS, the studio, the SQL Server Management Studio, and you saw that there is that Visual Object Explorer, and you can, let me show you. Okay, let me see what, let's look, for example, here. So you can go here, open a table, and here, and columns, and you can see that it's a primary key. So it usually primary key has no duplicates, so it should have no duplicates, this course ID, and that means that there is few chances that it will have the duplicate. So that's one thing which you can do before, in order to understand if it has duplicates. Usually you can also see here in keys, you can see primary key for school course. You can see that it's primary key. Or sometimes it can be said that it's unique and so on. But you will find out that as you work more with this, with the SQL Server more. So back to presentation. 1 second. This one. That's one way to avoid this. The next one is test the uniqueness. You can just write maybe count, use a count and group by business entity ID and see what shows you the count. Whether there are, for example, 16, you have a count of 3 equal to 3. It means that there are 3 records which have 16. It's already a duplicate. Or you can check the documentation where there is mentioned information about the table, whether it's primary key, whether it's unique or not, and so on. So those would be the steps in order to avoid this trap. So finally, we did this change. The salary is now the one which marketing manager has. So he is happy or she is happy. And she's happy that it's correct, but probably he or she would be happy having that higher salary. So that's the solution, and these are the way to avoid it. So these were the most important traps which I would like to mention. And be careful to avoid them. Of course, sometimes you just find out once you made the mistake, but it happens, especially when you are at the beginning. Okay, let's see then the best practices for you to follow when using SQL Server. So we are at the end, and let's see what's the most basic best practice you should follow when using SQL Server. So I would recommend to use alias for tables, because of course it makes the code more readable. It's much easier to follow the columns by those. So yes, for sure, I recommend you to use the alias for tables. And as you can see, I'm using here a letter. Of course, it's good to give something meaningful that it's much easier to understand and navigate than through columns by saying, okay, it's E, it's employee, so it's business entity from employee. So if you give an alias, try that it be a meaningful one. Then use table alias as prefix for columns. Yeah, it's the same, quite the same. So if you use here the alias, use it then within the columns, because it helps, it makes the code again much easier, and it helps you avoid the ambiguity. Because, for example, here in this part, in order for SQL to understand to what column you refer to, you should specify exactly from what table it comes, and it's better to use the alias and not the whole name of the table, because then it takes less space, less text to read, so it's much cleaner and easier to read. Another best practice which I would recommend is avoid using columns from the non-preserved table in where clause. That's one of the traps I've mentioned, as I think, yes, at the first. So like this one, avoid using the tables and the columns from the table, which is not preserved. Here it's left join, so the left side is preserved, the right side is not preserved. And if you are using this part, you lose these rows. So try to avoid using in where clause when you use outer join, to not use these to not use the columns from the non-preserved side. Always, another recommendation, always read and check the relationship between tables and its columns when joining tables. That's primary keys, foreign keys, how they are connected. You can do as I showed before in the SQL Server Management Studio, or if you have the documentation, that's even better. You can read the documentation, see which column is the primary key, which one is the foreign key, how those connect between, how those connect the tables, and which column would be better to use. So if you have that information, always try to use it. And finally, whenever you are joining tables, you should ask yourself some questions. And the most important, which I would recommend, is these two. If you're losing accidentally any rows when you are joining, or if there are any unexpected duplicates, always ask yourself about that and check the results of the join. Check the tables, the number of rows before the join, then check it after the join, the number of rows, and see if those number of rows are different, and if different, try to understand why, because you never know when you can have some rows that you lost, or some duplicate rows. So that this would be the most basic best practices. Of course, there are a lot of others, but when you start, I think these are the one which you should follow, and these are the easiest to remember, because you cannot remember all the best practices. So that's for the best practices, but that's not all. I have some bonus for you. So it's, if you want to go deeper with the T-SQL, with this transactional SQL, which is mostly used by when you use the SQL Server Management Studio. There are some official sources. I have presented just a part of the information. Of course, it's impossible to present in the presentation everything about joins. You can find even more information about joins on the official site of Microsoft. There is documentation. You can go on this link. There is a lot of information. You can read about the joins, and not only about all the statements, all the clauses that are used in the SQL Server. And also, I would recommend you to read this book, which is written by Itzik Ben-Gan. It's a very good one. I even did this presentation based on that book, inspired a lot from that book. The author explains quite well and in an accessible manner. And there are a lot of topics, and it's quite easy. It's for beginners. Highly recommend to read, at least to look in that book for some chapters that might be interesting for you, because the book is quite big. It has quite high volume. Of course, some key shortcuts to use, some keyboard shortcuts to use within the SQL Server Management Studio. If you are going to use it, it always helps you to work faster and efficient. So you can just look in that list of keyboard shortcuts. And if you want to practice on a database which is as much close as possible to the business data, then I would recommend you to go on to follow this link. You will find the well-known AdventureWorks database, and install that database and maybe play with the data. Maybe try experiment with some joins, or maybe some other statements from SQL, or whatever you want, just to get a feeling of how with what data you might work when you will get a job, because it's much easier when you understand how this connection works, that there is customers, there is sales order related to customers. So there is, for example, these job titles, there is pay rates, that they can be in different tables, and that you can understand when you work with the database which has a business data in it. I mean that in that case, if you practice a little bit, you are better prepared for a real case, which you probably will have when you get employed. So that's all from my side. Hopefully it was clear enough.